Yes, I think we should continue with Finn Jensen now. And thank you very much, Florin, and Finn, welcome. And we look forward to hear about the renewable energy supply for remote research facilities in Greenland. Thank you for joining us. Please go on.
Thank you, Morten. Nice to be here, or at least be here by Zoom. As you might see, some of you know that the background behind me is actually the view from the conference center. So we can have a little feeling of how it's up there. Very nice. I miss it very much. Okay. I will talk about the energy supply for remote research facility in Greenland, which we have been working on and are still working on. Actually, it's remote research facilities. It's just a container, but I'll come back to that anyhow. Yes. Okay, I'm from Aarhus University, which is actually situated 125 kilometers from Hurup. Hurup is here, and we are on the east coast of Jutland. Actually, it doesn't matter much now, but anyhow, it's a good distance to you up in Thy, and we enjoy it very much. Aarhus University, I'm at the moment at the University School of Engineering, but from next year we'll be transferred to Department of Electrical and Computer Engineering. And that will basically means nothing in the short run, but it can lead to some confusion of where I am from. But that's just why I mention it. Okay. The renewable energy supply for remote research facility in Greenland is called. It's actually a collaboration at Aarhus University, where we have the Arctic Research Center, ARC, that is in charge of measuring climate impact different places in Greenland. What they do is we have a project running for 5 years where we'll be measuring atmosphere, cryosphere, terrestrial, limnic, and marine conditions at Greenland. Limnic is maybe not all of you that know, but it's the ice and the freshwater solution compared to where the marine is the salt water. So that's what basically they would measure everything they can think of in Greenland. And at this address, the Arctic AU, you can actually see some very nice videos from the spot we're measuring there, if you go into that afterwards. Okay, what we would like is that we would like to build up a mobile measuring unit. That's the container I talked about previously. We will dump the containers at 5 different places along the east coast, from the north of Greenland to the south of Greenland. And it will be in remote areas, so there will be no external power supply. There will be no people on the ground, and it will be also measuring through the winter and through the summer. So it will be all year round, it'll be measuring. And the data will be sent home in real time, so you can evaluate on the measurement all the time. And based on this, we have some huge reliability issues, because we need the system to be very reliable, and we need to be able to trust that we can have power all the time. So that's some of the challenges in this project. Okay, we have there's built up in 3 parts. The first one is the main container, as we call it. It's for the where the data are sent home and from lots of measurements, and also the power supply, which we are responsible for. Then we have separate spots where we measure terrestrial. We take a lot of photos of the plants and stuff like that, they will have their own power supply, and they will be connected to the main container by Wi-Fi. That can be up to 5 kilometers. And then we have the third one, that's the marine system where we'll go in the water, have a cable, underwater cable in the water and do some measurements. And then we have this will of course be a wired connection, and the power for this one will come from the main container. So we also have to supply power through a cable up to 100 meters. So we also have to do some short circuit calculations and voltage drops in this 100-meter cable in this one. That was the general overview of the system, what we are responsible for at the School of Engineering. It is we have to design the power supply system. This one, automatic, reliable, and we can use solar, we can use wind, and we can also, of course, need battery storage to store the energy. To store the energy. The good thing is that consumption is very well known. We know how much power is used because it's completely automatic, and we can even control it. We have a priority list so that we can switch off some of the supply in case we have some failures on the supply system, or if we are running low on energy storage, then we can switch off some of it. They will not be happy to do it, but they can do it. So that's a good thing. Also, the locations are well known. I go back to this one. The locations are well known. These 5 spots. So we have the data for the spots. They can and will be used. So that's a good thing. The bad thing is that we need to put it there for 1 year and cannot service it and cannot get out to it for 1 year. So we need to be very sure about the system, and we need to be very sure that the dimensions of the solar, the wind, and the battery are correct. Okay, the work is done by me. I'm supervising this project, and of course, you know, I have all the works are done by students, and I have a very good student, Signe Madsen, she is doing all the heavy lifting, as you might imagine. Okay. As I told you, the locations are well known, and we take the data from several places. We have the Global Wind Atlas located at this IP address, and this is of course the wind. You can see here, I zoomed in on Greenland. This is where we get the wind from. Also NASA has a very nice online data portal also. This is also wind, but also sun irradiation and stuff like that. Both of these are supplying us with data on a daily average basis. And I'll come back to that in a little while, and that is actually a problem that we don't have better data for based on this one. But the Danish Weather Service, DME, they will be making some data available on hourly basis from next year. Actually, they might be there already, because I heard rumors last week that they were ready with the data already now, but we haven't had the time to look at them. But they will be based on hourly basis, and that will be exactly the same data as in ASE, sun, the sun irradiation, the wind speed, and stuff like that. Very, very. I'm looking very much forward to these data. Okay, so if we look at the first place, we will put up the container Daneborg or Sagenberg. It's a dual name, and that's so I can switch between this. Sagenberg. We have the irradiation. I'll talk about sun for a little while. This is for 1 year. We have no sun in the beginning and the end of the year, and then we have this profile here. And the scale is kilowatt hours per square meter. That's per day. So of course we get much in the summertime and less in the spring and the autumn, and nothing in the winter. This is for when we place it horizontal. If we have some solar panel tilt angle, we can increase it due to be more adapted to the sun. And if we zoom into this one, we can see that the optimum angle is actually changing, because here in the spring, where the supply is lowest, the angle is different than in the top where the supply is much. But as we have excess supply of power in the summer, we need to lift the supply in the spring and in the autumn, and it's not important how much we do in the summer, because it's very much here. So actually we have calculated that the optimum angle for the tilt angle in Sagenberg is actually 78 degrees. So that is a very steep angle. Another advantage is that if we have some snow, it will easily fall off at a high angle. So that's a good thing. Okay, if you move on to the southern part, you can see that here we have more supply in the winter for the sun. It's much more diverse than the other one. It's more flat. But again, the optimum angle, if we do the same calculations, is 78 degrees. And that is important because we need to have the most power from the sun at this time here. Okay. But solar is only one part of the issue here. We also have, of course, the wind. And then again, we look at the wind daily average. Again, at Sagenberg, the first spot where we will put the container, we can see this is the daily average of it over 5 years, starting in 2015 and all the way up to 19, end of 19, so it's actually 5 years. And we can see that we have some average wind speeds that is going up to 25, 20 meters. That's very high. But it's normal for Greenland. If we take the histogram and the daily average, we can see that actually we have 80% of the time is below 5 meters per second. 5 meters per second. We have around 35 below 2.5, and we have 45 between 2.5 and 5. So this sums up to we have 80% down below 5, and only 7. That means the remaining 20% is below over 5 meters per second, and approximately half of that 10% is the 7.5 meters per second. And that actually is a big problem, because we have looked at the one of the windmills, the LE V150, which is very much used in Arctic areas, because it is storm-proof, as they call it. It's designed to withstand up to 35 meters per second. So that is a problem, that most of the time, if it's below 5 meters per second, it doesn't deliver anything. And if we go back to that, we can see that 80% of the time, the windmill doesn't deliver anything. So maybe this one is not a good choice for this application, and we are looking very much into this one to looking at another windmill. But I'll just continue with this windmill here. One other thing is that also that, as I said at the beginning, the data we have now is daily average. And if I look into one date on the 26th December last year, then the daily average was 4.5 meters per second, which means that the windmill wouldn't deliver any power. But if we look at the hourly data, which is coming from Danish Weather Service, then it looks like this one. So you can see that even though the daily average is 4.5 meters per second, we have in the beginning of the day 6 or 7 hours, maybe we count this one over also here, hours where it was over 5 meters per second, and the windmill would in fact deliver some power at these 6 or 7 hours. But in our calculations based on the daily average, we don't get anything out from it. That's a problem. We need better data from this one. Okay, if we go back to the combined production at Saggenberg, you can see here that this is again over the 5 years period. We have the solar production. We can also then take a scenario with 1 windmill and 2 windmills. The red one is the consumption. So this is a straight line, and as you know, as we know the consumption here, because it's an automatic system, there's no human influence on it, so it's absolutely a straight line all the way. That's a good thing. If we compare this one, we can see that the blue one, this one is the production with sun and 2 windmills. The yellow one, which is close to the blue one, that's the sun, and then we have a slight one which you're barely able to see. That's 1 windmill. So that is how it looks like. And if in this area we produce more power than we consume, and in this area we consume more than we produce. So we have calculated what happened here? Oh, sorry. What happened now? I'm sorry, I lost my screen. I'll be right back. I was here. So, can you see my screen again? Okay. Yeah, just have to switch on this one. So, what we did is that we calculated the number of days where consumption is not covered. If we have no windmill, we go at Saggenberg approximately 160 days without an excess power supply. If we have 1 windmill, it's a little bit better, because there's some years we don't get so long, but actually in the 5 years, we have 3 out of 5 years we will go 160 days. And 2 windmills, it's a little bit better if we can go down to 100 days where we need the battery to supply the power. 100 days of battery supply in the power. So that is basically a very long time we need to rely on the battery, and doesn't get anything from the windmills or the solar panels. If we go to Nanortalik, which was down in the south, it actually gets a little bit better. One of the things is that we have a less area where there's not much power supplied. And also the wind speed is also better in this area. So if we again look at the data, where the blue one is the production with 2 windmills, and the straight red line is the consumption, and the green one, yellow one is only sun. We can see that actually we have a lot of better days here in between where we can get some supply. I have a delay. Oh, it could. This one, yeah. So actually that's wrong. That should be nanothermic, this one. Sorry for that. If we have no windmills, we can go 100 days battery storage. If we can go 1 windmill, we will be between 50 and 80 days. And if we go 2 windmills on nanothermic, then we're actually down to 40 days of relying entirely on the batteries. And again, the task to be looked at is basically one of the issues is that we want to lower the energy consumption. So we need to tell the researchers, the scientists, that we need to look at some better equipment that is low power. We also need better data, and we know that the hourly data will give you more precise results, and we are eagerly awaiting for those to arrive so we can repeat the calculation with these data. Now we have the procedure, so it's just a matter of number crunching to do that. And secondly, or third, is that we need to look at a windmill that can deliver power at lower wind speeds and still survive in Arctic storm and still survive polar bears. Actually, that is one of the issues that we had from our test facility, which we ran last winter, that has to be polar bear proof. We have some pictures of polar bears attacking the system, so that's very funny. Okay. Thank you for your attention. I'm sorry for the mix-up with the slides in the middle. And if you have questions, then please come with them. And also, if you have time, then you should look at the very nice videos that I showed a link to in the presentation. It's very breathtaking view at Greenland. Thank you.
Thank you very much. Finn Jensen, you can put that in the chat if you want, and then people can take it from there.
Yeah, I can do that.
Yeah. Thank you very much. It's very interesting. Especially
well, it's still work in progress, as you can see.
Yeah.
So, but I think we have some very good calculations of the the data based on what we can do.
Yeah. There might be some questions. Anyhow, I have some questions, but first I'll ask if there are any of the audience who have some questions for Finn Jensen. Not right now, it seems, but then I would like to ask you, what is the lowest temperature actually you're working in at the northeast Greenland?
Northeast, I have to say I'm not quite sure, but at Danneberg we are not down to minus 30 degrees.
Minus 30, yes.
Yeah, but actually, if we do something about the container, then we can get it to minus 10 degrees inside the container.
Okay. It's interesting. Well, I don't know if you heard the presentation from George Kekeletse about the Russian conditions, and therefore, if there could be taken any comparisons from the Russian and Greenland studies, and also that I don't know if you're working with the institutes in Russia or cooperate with them because, well, maybe there is an access to some new knowledge for you.
Yeah,
But,
the temperature is a bit of a problem because of the batteries. Yes, exactly. Yes.
Yeah. Well, but Fritz Ock has a question. Please, Fritz.
How about doubling the capacity of the batteries?
Yes. How about money? Yes, it's an issue about money. Yeah, we will exactly. We'll try to have a prioritize investment cost versus cost to reliability and to have a secure power supply. That's an issue. And hopefully we will hopefully see that the battery prices will drop so that we can have more battery storage.
Thank you.
And then there's a question about thermal storage. It's a very low system, so I don't really think we can have a low thermal storage in this facility. I think it will be complicated to do that. But we haven't looked very much into it. No.
UNAFCO, the American research organization, use thermal overcapacity to heat the batteries.
Yeah. But the problem is that we don't have overcapacity in the time when we need to heat the capacitors, because it's only in the summer we have overcapacity.
Well, there's another two questions from Falk. And someone with a lot of numbers and letters. Falk, will you come first with your question?
Yes.
Please?
When are the systems being installed in Greenland?
We had a very limited test run last winter, so and we're building up a container here in Denmark on an island now. So I will probably be thinking maybe next summer or the summer after that.
Yes. And then there's one called C3058761. There's no name, but please come with your question.
I believe I answered that one, but it was of the benefit to thermal storage as the price speaker, and I think we didn't consider that one.
Okay. Yes. You said that the size of maybe I lost something, but the size of your equipment is I suppose it's quite small sizes, but can you give us a figure or an idea about how big it is?
It's a 20-foot container.
A 20-foot container.
Yeah.
It's all in there.
Yes, exactly.
Yeah. Okay.
And then we can also have some insulation in the container. So we're not using all the space, but we need to be very robust. We need to be polar bear safe.
The research you're doing might have an influence on the commercial life as well, because I think that the results that they're doing can be used somehow, especially for the demand we heard about in the first presentation from George Kagaletsky in Russia.
Yes. Yeah.
When do you think you have results which will be available?
Yeah, it will be 1 year after we install it. So I think we do it maybe this summer. Actually, I don't know, because we have been a little bit delayed. But then next summer we will have some results.
Yeah. Well, if not more specified questions for Finn Jensen, I think that we'll go to this round where, because of Dr. Galal Osman has failed to participate today, but we have some time here where we can use for questions, because we not really finalized with George Kekeletske, and I hope that you are still on, George. And with Florian Job also, that there might be some questions for him, and if he wants to have some final things to say, we have about 25 minutes before the break. First, I think that we will ask Florian Job, was there anything, because I will not call it abrupt, but anyhow, we had to finalize at that time. But anyhow, I have a question for you, and we see that turbines are. He's not online. Oh, I see. Oh, he'll join later. Okay, okay. Are there any questions for George Kekeletske about these the possibilities in Russia and in Georgia? And or comments to be put up right now? Well, it seems not, but I have a question. Because George, do you think that it will be possible that there could be some kind of cooperation between the Danish scientists and what you're doing in Russia? Because you, of course, have some knowledge about the Arctic, but at the same time, we also do some research in Denmark. I'm not sure we're doing it the same way as you are. You might be much more experienced since you have worked with it for more years than we supposedly have. But do you have any comments on this?
Well, I suggest, first of all, thank you very much. It was very interesting for me to listen to Finn Jensen's presentation. Yes, what we could do is we could put up I would not specifically say Danish Russian, but maybe let's say European Russian, because you also have participants from other countries here, right? Not only from Denmark, but something that we can do is we can put up a quick seminar. We can find a little funding also for that. Maybe invite some colleagues from Germany or Switzerland as well, work on the same topics, and then we could bring in the institutions from the Russian side and have it, let's say, on the applied research. So identify the applied research and see what is necessary from the point of view of identifying the finances for that, so that we can go directly from applied research into the installations. Because as I said before, there are a lot of nice researches done, but the key is how do you go from the product into the installation stage, and this is where we come in, and Morten and you and I can probably concentrate in this area. I suggest that we could do something like that in the first quarter of 2021. We will communicate with you with the institutions that we can line up on our side, and then maybe we can have such a, let's say, seminar on these topics in the first quarter. What do you think?
That would be very nice. Yes.
We also have Norway and Svalbard.
Yeah, I'm also talking to Torsten from Norway. I guess he said he might be here this year, but I haven't seen him.
Yes, might be.
Yeah, okay. But I was also talking to him. He has also some installations in Svalbard and North Norway.
So we can go topic by.
Thank you, George. I will come back to you on this one.
Thank you. Thank you.
Yeah. Very interesting.
Yes. Are there any other comments right now in here? as a follow-up on the morning's presentations? It seems not. The experience which we have got during the Corona time, anyhow here in Denmark, is that people after about 1.5 to 2 hours are losing concentration. So therefore, breaks are very important. So I'll just suggest that we now take a break, and then we continue in a good half an hour. That means 11:45, and there we'll continue with the global small wind markets status with Jean-Daniel Bidlot from World Wind Energy Association, situated in Bonn, Germany. But let's take a break and stop for now. And everybody, please make your thoughts and make some questions for later, because we'll make some follow-ups because maybe suddenly something appears to you, and you'll then take it up. Florin, has Florin come back? Or especially if you have any questions for Florin, it seems as he's not back yet, but we can take it up later, and we'll ask him to be online again. So yes, that's for now. See you in half an hour, a good half an hour. Thank you.